Hi, welcome to Algebra 2, Chapter 7, Section 1. My name is Mrs. Shiwi, and I'll be teaching this lesson today. I just wanted to share with you that Chapter 7 is on the principles of probability, and then statistics as well. Goes into Chapter 8 a little bit, but these concepts are very important for you to know. Some of them you may have learned a little bit of in middle school math, but we're going to extend on those. And also they're really important pieces for when you go to take the SAT, ACT, state testing, and also when you take a placement test for college. If you're going to a college, they do a math placement test to see where you should be. This is one of those concepts that comes up. It's not necessarily essential for the next level of math, like pre-calc. We don't really do much with probability, but it's really good. Kind of a different branch of mathematics that you need to know about. So we're going to get started here. We've got section 7.1. We're going to start off with the fundamental counting principle. It's fundamental, so that's a good place to start. Basically, that gives you the total number of ways different events can occur. So here on the screen, hopefully you can see this picture of a lunch special, and these notes are available to print out and follow along with me as well. For the lunch special, you can choose an entree out of the 3 choices here, a drink out of the 4 choices, and 1 side dish, and that would make a meal. So fundamental accounting principle just says, since we have 3 entrees, 4 drinks, and 3 side dishes, we can actually just multiply those different number of outcomes together to figure out how many different combinations of meals I could come up with from this menu. And so the answer is 36. So here's just another example right here real quick. If you want to take a moment and try to answer that, please pause the video and answer the question. At this yogurt shop, picking 1 flavor of yogurt, 1 kind of fruit, and 1 type of nuts, how many different yogurt parfaits can you make? Pause the video and answer it, and then come on back. Since we have 2 flavors of yogurt, 1, 2, 3, 4, 5 options for fruit, and 3 options for nuts, we have a total of 30 different parfaits that we can make. One more question down here. In Utah, a license plate consists of 3 digits followed by 3 letters. And a lot of states are this way. Sometimes it's letters first. The letters I, O, and Q are not used because they're hard to read from a distance. And each digit or letter may be used more than once. How many different license plates are possible? So the first is 3 digits. Digits are the numbers 0 through 9. So there's 10 options. And we may use them again. So I could have like 1, 1, 1, 2, 2, 2, 3, 3. So I have 10 options for the first spot, 10 options for the second spot, 10 options for the third spot. And then we're following up with 3 letters. So each one of these is a letter, but they do not include these 3. So there's 26 letters in the alphabet minus these 3. So there are 23 options for each of these spots. And the fundamental accounting principle just says that I get to multiply all these numbers together, and that's how many different license plates I can make. This comes out to 12,167,000 different combinations of license plates. Now you know that now there's a lot more options with personalized plates, and sometimes you can put another digit in the center of your license plate and things like that. So there's even more combinations that we can come up with. All right, for the next slide here, we've got factorials. So when you have some items, there's different ways to arrange them. If you only have 1 item, of course, there's only 1 way to arrange that. You have it. If you have 2 items, you can have the first and then the second, or the second and then the first. If you flip them around, that would be 2 different ways to arrange them. And if you add a 3rd item, like ABC here in the example, you can have 6 different combinations of ways, because there's 3 options for the first letter, and then one of them's been used. So there's only 2 options left for the second letter, and then one of those has been used, and now there's only 1 option left for this last spot. So you can go 3 times 2 times 1 and get your answer. If I had n terms, I would have n, and then one less, and then one less than that, and one less than that, one less than that. And I would, using the fundamental counting principle, I would multiply all those answers together to get my answer. So this expression is called n factorial. And what it means is if you have 5 factorial, that's 5 times 4 times 3 times 2 times 1. And that can get big really quick. This one's not too bad. It is just 120. Pardon my dog. And then 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. Gets really old really fast. That's why we came up with this math symbol for factorial. This answer is 5040. It also takes a long time to type that out. So there is a button on your calculator. If you have a TI calculator, you go to Math, which is in the top left buttons. And then across the top of your screen, you'll see some different things, and you look for PRB for probability, and you're going to arrow left or right to get to that. And then I believe on most of them, it's number 4, but you're looking for the exclamation mark. So if I was typing in, for example, 13 in my calculator, I would go to 13, and then I would go to Math, probability, exclamation mark, and it would, on my screen, should show 13 factorial. Hit enter, and you get the answer, because we don't want to type in 13 times 12 times 11 and so forth. But the answer to this one comes out to 6,227,000. Nope, million, sorry. 20,800. Trying to write and talk at the same time. So huge numbers. Definitely will be able to use a calculator on questions like that, or you just leave it as 13 factorial. So when we are talking about how things are arranged in different ways, we talk about whether the order that they're in matters or not. So a permutation is a group of objects in which the order is important. If you are pulling names out of a raffle for first place, second place, third place, the order matters because the first place prize is usually better than the second place. If you are just selecting a group of people from a group of 7 people, then the order that you pick them in, if you just want like a committee, the order doesn't matter. But if you want them to be first, second, third place, then the order is important. So the way I remember this is that permutation starts with P. So like place, like as in first place, second place, third place matters. So for like the fundamental counting principle, if I had a group of 7 people and I want to choose 3, how many people can I choose for the first person? Well, how many raffle tickets or tickets with their names on them are in that pile? There are 7. Now that I have selected that one, it's gone. So for the second place, there's only 6 people left because you can't win them both. There's only one of each name in there. And for third place, those 2 names have already been pulled out, so there's only 5 left after that. So we can multiply these 3 options together, and there are 210 possibilities. Another way is something called permutations instead of the fundamental counting principle. And the permutation uses factorials. You take the number of arrangements of 7 people, factorial, and you divide it by the number of people not being used. So since we had 7 people and we are going to keep 3 of them, there are 4 people not being used. So if we do 7 factorial divided by 4 factorial, just mathematically what that would look like. 7,654,321 over 4,321. This is multiplication, so I can cancel like terms. And so what I have left up here on the top is 7 times 6 times 5, which is exactly what I had in the first problem there. So what we just did here is the formula basically for a permutation. So if you have, for us, if you have 7 items and you're picking 3 of them or permuting 3 of them, then you would have 7 factorial over 7 minus 3 factorial. So there's the example that we just did, and here is the formula for it. This is a formula you're going to want to know. So make sure you have that handy or highlighted or circle it or something. All right, so here are a few examples. Just going to use that permutation formula, make sure we know how to set it up. If you want to work them out on your own, you could just pause it and then fast forward to when the answers are on the screen and check your answers. I'm going to go ahead and work them out. So pause the movie now if you want to do it yourself first. All right, sample permutation problems. Number A. How many ways can a club select a president, vice president, and secretary from a group of 5 people? So when you're setting this up, you're always going to start with the big number or the total number of options first. And then it's a permutation, and how many people you're picking in this case is 3. And so now I know I have 5 people and I'm picking 3. I can use my little formula, 5 factorial over 5 minus 3 factorial. 5 minus 3 is 2 factorial. So my fraction would be 5 times 4 times 3 times 2 times 1 over 2 times 1. So my total number of people is 5 times 4 times 3, which is 60. So there's 60 different ways I could select these positions out of my group of 5. Seems like a big number, but there are a lot of ways to arrange that. Part B, an art gallery has 9 photographs from an artist and will display 4 from left to right. That is key in deciding that the order does matter. If I was just choosing 4 to display and order didn't matter, this is a different story. Order matters. We've got 9 items and we are picking 4 of them to display in order. So that's it. This time, let's just say we use our calculator. So we can do 9 factorial over 9 minus 4 factorial. You can either type it in with the factorial, you can work it out, you can use the permutation button. Oh, that's also in there. I didn't say that before. You can also press math and go over to probability and choose the one that says NPR usually. In the older calculators, in this problem, you would have to type 9 first and then find that button and then the 4. And that's how you type it in your calculator. Anyway, the correct answer to this one is 3,024 different ways to display those 4 photographs in different orders. Part C, how many ways can a stylist arrange 5 of 8 vases? I have 8 vases and I'm arranging 5. Make sure the bigger number goes first. If your bigger number is not first, that's not going to work out. Find a way to compute that calculator or writing it out. And I got 6,720. All right, so I've been touching on the order matters part a little bit. If the order does not matter, you end up having less ways to arrange them. For a really quick example, if I have 2 people and they're shaking hands, there's only one handshake that happens. Me shaking your hand and you shaking my hand are not 2 different handshakes. That's one handshake. So we wouldn't have 2 different arrangements. We would only have one. So what happens is you end up double counting the different arrangements. So we call this a combination. So this would be picking 3 people to be on a committee. And it doesn't matter who was picked first. Just all of those different arrangements are still just like, if you have 3 people, there's 6 different ways to pick them. That's really just one combination. 6 different orders. So there's a formula for combinations. The difference in the formula, you'll see this extra little R right here, because how many ways are there to arrange those 3 items? There are 3 factorial ways. So I have to divide that out because I was double counting it. This formula is also programmed into your computer, so you can find that under the math probability menu. And we can also do a couple by hand, just so you know what's going on. So read the problems carefully. Katie is going to adopt kittens from a litter of 11. How many ways can she choose a group of 3 kittens? She's choosing kittens to take home and keep. They are not going to stay in the same order. They're kittens. So we have 11 kittens and she's choosing 3 to keep. Big number always goes first, but this time we have a combination. So when I go to do the formula, it will be 11 factorial divided by 3 factorial times 11 minus 3 factorial. So it's just like the permutation formula, but there's this extra R value factorial. What does that look like if we write it out? I'm going to take the time to do that here. 6, 5, 4, 3, 2, 1 over 3, 2, 1. And what is 11 minus 3 is 8. 7, 6. Okay, you get the idea here, right? These are all going to cross out. And so the math is just 11 times 10 times 9 over 3 times 2 times 1, which we can divide and see what we get. Not divide, well, multiply and divide. 11 times 10 times 9 divided by 6. That'll work. 165 equals 165 ways to choose 3 kittens. If you did a permutation and you did them in order, it would be a completely different story. And that concludes lesson 7.1. See you next time.